Until today, the only way you would know how to do this problem because of this 3 in front of it is to do this using long division. Okay, I'm going to show you what you need to do in order to be able to do synthetic division with a problem like this. There's a couple nuances, one with the actual synthetic division and 2 with the remainder, and that's what we're going to focus on today. So it's because of that 3 in front of the x that we can't use synthetic division. Okay, this has to be x by itself, or in other words, the coefficient has to be 1 in order for us to set up synthetic division. Okay, so what we're going to do is I'm going to show you how to do that. Notice here it said we can't use synthetic division yet, and that's because that coefficient is not 1. So what we need to do is we need to get rid of that 3. Okay, and the way that we do that is we're going to divide everything by 3. Okay, every part of the divisor, we're going to divide all this by 3, and then we're going to divide all of these by 3. So when it says we divide both the divisor is this, and the dividend, that's this, we're going to divide everything by that coefficient. So the way I've written it here is for any kind of problem. So whatever this coefficient is, you're going to divide through by it. In this case, it's going to be 3. Again, the reason that we're doing that is to turn this into 1x, or just x, because that's the way it has to be set up in order to use synthetic division. By 3, this is what we're talking about. So those of you who are still uncomfortable with fractions, this is going to make you pretty uncomfortable. Now notice something here, okay? Because we are missing a constant term here. Remember that there should always be one more term than the highest power. And here, I only have 4 terms. 1, 2, 3, 4. I need that 5th term, that constant term. So notice here I added the 0 for the 5th term, because in reality, in order to do synthetic division, and actually to do long division, we need it to be plus 0. We need to have that extra term so that all the spaces are filled. Okay. So that's why you see that 0 divided by 3. It's because of the fact that we're missing a term here in this polynomial. Now, wherever we can here, we want to simplify these fractions if possible. Okay? So I'll be able to simplify this here. Really won't be able to do 5/3. This will just become 1/3. 7/3 I can't reduce. This will just be 0. This will be a 1, which is good because we want it to be 1x, and then we'll have this plus 1/3. We want to simplify those whenever we can, and so we can zero in on what the coefficients actually are. Because now that we have this as x by itself, coefficient of 1, I can use synthetic division with this. So yes, you're going to have synthetic division that contains a bunch of fractions. So for some of you, if you get the choice, some of you are going to prefer long division in a problem like this than synthetic. But you're going to need to know how to do it both ways. Okay? Okay? So again, I have negative, because we do opposite sign here, negative 1/3 here, 1 for the coefficient, negative 5/3, positive 1/3, 7/3, and 0. So go ahead and do synthetic division on that. Once we get it down to that, the setup for synthetic division is the same. Here's what you should have had. Okay? So you bring the 1 down, multiply, negative 1/3. When I combine these together, I get negative 6/3, which is negative 2. When I multiply negative 1/3 times negative 2, I get positive 2/3. When I add them together, I get 1. Multiply negative 1/3 times 1, I get negative 1/3. This is 7/3 minus 1/3, which is 6/3, or 2. Negative 1/3 times 2 is negative 2/3. Combine those together, and there's my remainder. How many had that? Okay. Now, again, you got to be really careful here, especially those of you who struggle with the fractions. Okay, you've just got to be careful. Make sure that you've got your numbers straight. So now what we have to do is we have to write this in polynomial form. Okay, these are all just the coefficients. So remember, I go one tick down from the highest power. So this is the x to the third. This is the x to the second. This is the x. This is the constant. And this is the remainder. So this is what it looks like so far. Okay, x to the third minus 2x squared plus 1x, or x, plus 2 minus 2/3 over x plus 1/3. So when we put it into the remainder form, we use the new divisor, not the original divisor. Okay? When we work with synthetic division, we use the new divisor. Now, here's the next issue. The next issue is with this remainder. We don't like to have fractions inside of fractions. And in the next couple slides, I'm going to show you how to get rid of the fractions within fractions to make that remainder a little more tolerable. Let's talk about how to simplify this a little bit more, okay? And then we'll be able to write this a little better. So we've got this remainder, fractions inside of a fraction. As a general rule, here's what you want to do. Okay? You want to multiply the top and bottom by the lowest common denominator to get rid of the fractions within fractions. Okay? So go ahead and write that down, and then we'll talk about what that means for this problem. So what is the lowest common denominator between the top and the bottom? 3. Okay, so if these denominators were different, then we'd have to find the lowest common denominator between them. But in this case, they're the same, so my lowest common denominator is 3. So then all I need to do is multiply the top and the bottom by 3, and we'll be able to simplify it down so that it's not as complicated looking. It doesn't have as many fractions within the fractions. So go ahead and do that. When I multiply negative 2/3 times 3. Negative 2. What about the bottom? 3x plus 1. Okay? So now what I've done, again, when I multiply the top and the bottom of a fraction by the same number, I've essentially just multiplied it all by 1. Right? 3 over 3 is 1. So I've changed the way it looks without changing its value. And this is a more simplified fraction, and it's preferred. So if you run into a situation with a remainder like this, you do need to take these steps to simplify it down. Okay? So now I can go back and actually rewrite the problem with my simplified fraction. Okay? All right. So the rest of it, this all stays the same. This gets simplified down, and we're in good shape. Okay? So again, in this last part of 5.2, we covered synthetic division, sort of the easier ones that were already set up for you. We covered long division, where the divisor had a leading coefficient other than 1. Now we can use synthetic division anytime. Again, for your quiz, you need to know how to do both. But today you've got work from your book and also a worksheet where you're doing nothing but synthetic division today. Okay, no long division at all today. Okay, and you're going to have problems that will turn out like this. So make sure you're careful with your numbers and your calculations so that things don't get messed up. Any questions?